Wow, nobody could have predicted this. Thousands of Airbus planes had to be grounded at once. Was it a technical glitch, a construction mistake, a human error? Not at all. It happened because the plane's computers might get messed up by something coming straight from space, something that could cause a terrible disaster and claim hundreds of lives. Now, the thing is, our sun is always shooting out charged particles, like a powerful invisible wind. And on top of that, we're constantly getting hit by even stronger particles from outside our solar system. Those are called cosmic rays. We never feel them, but they're always there. Most days they're harmless. But sometimes the sun fires off a massive burst, a solar storm. And that stuff can seriously mess with electronics. It's also what triggers those insanely bright auroras. Now, because of this risk, Airbus checked around 6,000 planes. About 5,000 of them needed a simple software update. But around 900 older planes needed a whole new computer. According to Airbus, radiation from the sun might have corrupted data that's essential for flight control. And this issue could have affected many A320 aircraft already in service. The main problem is a piece of software that calculates the plane's elevation. If high-energy particles hit the computer at the wrong moment, the hardware can glitch, and that glitch becomes a software error. You see, when planes fly high, the air is thinner, so more space particles get through. If one of those particles hits a microchip, it can flip a tiny bit. A 0 becomes a 1, or a 1 becomes a 0. That tiny flip is called a single event upset, and it can make electronics act weird. You can probably imagine the catastrophic outcome an altitude-related mistake can lead to. Airbus planes are finally getting back to normal after the company rushed out a software fix, which was way faster than anyone expected. By the way, the warning itself came after a JetBlue flight ran into trouble mid-air when a solar flare may have messed with its flight controls. That JetBlue plane was flying from Cancun to New Jersey when something suddenly went wrong. The jet dropped sharply. It was fast enough that people were thrown around the cabin. Some passengers hit the ceiling. Around 15 to 20 people ended up in hospitals. At 2:19 p.m., the pilots made an emergency landing in Tampa. Medical teams immediately rushed on board. JetBlue pulled the plane from service immediately, and the FAA is now digging into what exactly happened. In any case, these days, we rely a lot on watching the sun. There are satellites in space right now whose only job is to track solar tantrums and warn us before they cause trouble. Luckily, we're finally heading toward a calmer period of the sun cycle, but it never truly quiets down. Even when our star seems calm, it's still firing particles at us nonstop. And recently, scientists from several countries found something hidden in ancient tree rings, a huge jump in radiocarbon dating from about 12,350 BCE, right near the end of the last ice age. For years, no one could tell how strong this spike really was because there was no good way to model it. Now, with a new climate chemistry model, researchers have finally figured out that this thing was the most powerful solar particle storm ever found. Nothing else in the record even comes close. The team built a special model. It's designed to recreate how the atmosphere behaved during glacial times, letting them study ancient solar storms. And when they tested the model on a newly discovered event, they found it was even stronger than the famous AD 775 storm, which used to be considered the biggest one on record. Compared to a strong solar storm from 2005, the Ice Age event was hundreds of times more intense. Other big historical storms did happen long ago, around 994 CE, 663 BCE, 5259 BCE, and 7176 BCE. Hey, I wasn't around then. But none of them reached this level. The researchers also checked the model using wood found in the French Alps that dates back around 14,300 years, so the timeline lines up. Solar particle storms don't happen often, but when they do, they blast Earth with high-energy particles that can change the atmosphere and leave clear marks in tree rings. Even the famous Carrington event of 1859, which knocked out telegraph lines around the world, was actually a different kind of solar outburst. What makes this new discovery stand out is that it's the only known extreme solar particle event from before the last 12,000 years of warm climate. Until now, scientists could only look for such storms inside that window. But with this new model, the scientists were finally able to figure out how strong this ancient solar outburst really was when it hit and what it might have done to Earth. The model now works for both warm periods and for the cold, icy world that existed before it. That's a big step forward for studying old radiocarbon spikes. The team focused on how solar particle storms can pump huge amounts of extra radiocarbon into the atmosphere. Normally, this type of carbon forms when cosmic rays hit our air. But during one of these extreme storms, the amount shoots up fast, and trees trap that sudden jump inside their rings, which basically creates a timestamp that survives for thousands of years. These sharp spikes, known as Miyake events, have already helped scientists date things like Viking settlements in North America and early farming communities in Greece. This ancient blast sets a new upper limit for what our star can do, and it's alarming. Knowing the size of the event is crucial. A storm of that scale today could threaten satellites, mess with communication systems, and overload power grids. It gives researchers a clearer picture of the most extreme kind of space weather our planet might ever face, and what it could mean for modern life. Now, luckily, Earth is wrapped in a kind of invisible shield that blocks most of the dangerous particles the sun throws at us. For almost 10 years, 4 small NASA spacecraft, called the MMS mission, have been flying right along the edge of that shield, watching how it bends, snaps, and reacts to the sun's magnetic forces. Now, during one of those passes, the probes caught something nobody expected, a sharp twisting bend in Earth's magnetic field. Scientists call this kind of shape a switchback. They've seen them near the sun before, but never this close to Earth. Finding one in our space neighborhood is kind of like spotting a wave curling backwards in the middle of a calm lake. This switchback showed up in the magnetosheath, the turbulent zone where the solar wind slams into Earth's shield and gets pushed aside. Inside the twist, the probes picked up fast, energetic electrons that came from Earth's own magnetic field. They were mixed with particles from the sun, and everything was spinning together inside this strange structure. The spacecraft recorded how the magnetic field flipped, how fast the particles were moving, and how the whole thing behaved. The twist seemed to come from a process called magnetic reconnection, where magnetic fields from the sun and Earth snap together and release a burst of energy. These bursts can set off bright auroras, but the big ones can also knock out satellites or mess with power grids. The MMS probes will keep flying through the area, hunting for more twists and bursts, trying to pin down what causes them and which ones are strong enough to mess with our technology on the ground. The problem is that tiny magnetic snap might let radiation push far deeper into our atmosphere. And now, scientists are starting to connect the dots. Strange aviation glitches, signs of ancient megastorms buried in old trees, and now a fresh crack in our magnetosphere. Together, they paint a worrying picture. We depend on calm space weather for everything: planes in the sky, GPS, satellites, even the power running through our homes. The Airbus grounding might end up looking like a gentle warning, the first hint that something much bigger could be building out in space.